The focus of this video is on how to interpret the z-test and not really in how to generate the answer to the PERT diagram portion. So you'll notice here in front of you I have computed the expected time for this entire column here. So I have the expected time for all of the different activities. And then over here I've computed the variance, and I just computed the variance for the activities that I knew were going to be on the critical path. So I first calculated this column here, then I went down here and I drew my diagram. That was step 2. And then I computed it all out. Then I did this. So this was step 3, computing the variances, because I didn't need the variances for the activities that were not on the critical path. Once I had my drawing drawn, I could see that, first of all, it was sort of a pain to work with these decimals, that's for sure. And so you'll see that I had to zoom this way in order to get that box big enough that I could actually write those numbers in there at those decimals. So I'm sorry it's such a hassle. Anyways, at the end we determined that this project takes 40.168 units of time, weeks, or whatever they are, to complete. So we go down here and the project completion time is going to be noted there. So this is going to be computed as the sum of the critical path activity times. Then we go here to this next box and we're going to compute the sum of the variances of each of the activities on the critical path. So these variances that are listed here are only for the activities on the critical path. We don't want to list we don't want to add in there any variances for activities that are not on the critical path. So notice over here I say the sum of the critical path activities. Then I go to the next step where I've got to compute the standard deviation of the critical path variances. And remember from your stats days that standard deviation is always the square root of the variance. So if the variance, right here, I guess I didn't label it, so this is the variance, project variance, I bring that down here, I take the square root of it, and that's going to give me the standard deviation for the path right there. So now, this is the spacing for one standard deviation. So as you can see here, we divide this out by taking the amount of weeks in question, subtracted by the average time to complete the project. We divide it by the project standard deviation, this 3.167, and we get 0.895. We're going to look up this 0.895 right here on the Z-chart, and we're going to find the value that we get when we look at the Z-chart. So we'll go right over, we'll look at the Z-chart, and we're going to come back. This is the value we're actually going to find. I've already put it in here, but let's go ahead and flip to the Z-chart real quick, which is here. And what we do is we come down the left hand side and until we get to the 0.8, which is right there, and then we're going to come across where the green line is until we get to 0.09, and the way we see that is right here. So you've sort of combined the left column and this, so you get, essentially 0.8 plus 0.9, which of course is 0.89. Now on this one it's a little confusing because it ends up being 0.81, which is, quite close to 0.89, but nonetheless we take our 0.8133 and we bring it back over here, and we're going to write it right down here, 0.81327, I guess. So we'll just go with 0.8133, and we interpret that as an 81% chance of the project being complete, so we're just going to say project completion, in 43 weeks or less. Now, I'm going to also take some time to show you this graphically using the z-chart and the normal distribution. So let's go ahead and flip our attention over here to the z-chart. So when we look at this normal distribution, we know that 68% of the time our project is going to be done in between 37 and 43 weeks. So we add these two percentages together and we get that. Now I'm asking you the chances of this project getting done in 43 or more weeks. So essentially I'm asking you, so we're going to begin here with the idea of completing this project in 43 weeks or less. So let's just orient ourselves with this normal distribution. We've got right here is the mu, the midpoint on this chart, which is, we know on average the project takes 40.168 weeks to complete. So that is placed in the middle or at the 50% mark on the normal distribution. From there, we know that the next important mark is +1 standard deviation, which is right here, and -1 standard deviation, which is right here. And we know that the combination of this section, the navy blue, and this section together, this whole combination here, accounts for 68% of the normal distribution. So I've highlighted there in sort of a white color, right, with the little white stripes. So this middle section is 68%. Now we also know from previous discussions in this class that the 50% represents this from here all the way to the end of the origin here. Right, it is 50%, and then, you know, of course the other 50% is on this side, because the whole thing ends up being 100%. So it's all about these percentages and how they break down. So the question in front of us is 43 weeks or less. So we know that 43.335 weeks is 1 standard deviation, so 43 weeks is kind of right here. Right, it's not quite to 43.335, but it's very close. So the little pink dot represents the point of 43 weeks or less. So our question before us is, how much of the normal distribution falls between this little point right here and all the way down here to the origin, which is right there? So we could eyeball it, right? We could say that, well, if this is 50%, right, from here all the way back to there, we know that part is 50%. And this is really darn close to 34%. It's going to be close to 50% plus 34%, or 84% chance of it being 43 weeks or less, right? Because from here all the way back we think is going to be close to 84%. Now, it's going to actually be less than that, because the fall off between our white line and the next line over is a couple percentage points, because that middle section is so dense. But the way we know that for sure is we look it up on the z-chart. So we looked up the value on the z-chart and we got this 81.33%. So what this 81.33% tells us is that actually it's not 84, no, it is actually very close to 81.33% percent of the time do we expect this project to complete in 43 weeks or less. So 83% of the time this project will complete in 43 weeks or less. Now we're going to do the same exact thing with 43 weeks or more. I'm just going to outline this in pink so that we can see that's the 43 weeks or less is going to be represented in pink. So the next question is 43 weeks or more, which we're going to represent in this green color. So let's go back up here to our G chart. We still have the same critical point here, the 43 weeks, But now instead of the pink side, we want to go to the green side. So we want to go from here all the way out here. So we're talking about this. So we know that it's not 84%, and this whole thing equals 1, right? 100%. So it's going to be pretty darn close to 100% minus 84%, which is 16%. But we already know from experience it's not going to be exactly 16% because it's not actually 84%, but it's going to be close. So the way we figure this out is when it says 43 weeks or more, then we take 1 minus 0.8133 and we get roughly 19%. We're just going to go with 19%. It's actually 18 point something, but that's close enough. So what this says is that about 19% of the time this project will complete in 43 weeks or more. And if we go up here and look at it, we see it's this green part. It's a less chance. So the key things here is what question I am asking. You don't always subtract 1 depending on the question, because I could say, what's the chances that this project would complete in 32 weeks or more? Well, 32 weeks or more is going to be like down here somewhere, and then I'm going to be talking about all of this. So now we're not going to be subtracting from 1. There's no set way of doing this. You have to read the question and then think about this normal distribution and then choose your answer. So as you finish this video, I think it would be a good idea to do the same thing for 42 weeks. You should get a number pretty close to what I have here, but go ahead and calculate it out for 42 weeks. And so if I was to ask a question in the future about that, well then, you would know the answer. But it's very similar to 43, so you can make sure you're on the right track. All right, hope this is helpful. See you soon. Bye.